Unit 5 Simple Machine. 5.1 Purposes of Machines. By the end of this section you should be able to explain the purposes of a machine. List the types of simple machines. Determine whether the machines are force multipliers, speed multipliers or direction changers. Define the terms load, effort, work output, work input, mechanical advantage (MA), velocity ratio (VR), and efficiency. Derive the expression of efficiency equals mechanical advantage divided by velocity ratio from its definition. What are simple machines? You could probably list hundreds of different machines. These might range from the vastly complex space shuttle, down to a simple pair of scissors. A machine is a device that is specially designed or engineered to help make it easier to do mechanical work. Mechanical work is given by work equals force times distance. W equals work done in joule. F equals force applied. S equals distance moved in the direction of the force. A machine makes it easier to do work by performing one or more of the following: increasing the magnitude of the applied force, changing the direction of the applied force or transferring an applied force from one place to another, increasing the distance moved against the applied force or the speed the force moves. No machine can create extra energy that would break the law of conservation of energy. In other words, the work you put in cannot be greater than the work you get out. However, as you can see from the list above, it is possible to get more force out than you put in. We need to think about this carefully. When you apply a force to a machine, this is referred to as the effort. In order to do mechanical work, you need to move this effort through a distance. Looking back at our equation for work, we could rewrite this as W equals Fs, work input equals effort times distance moved by effort. The machine then provides a work output. This may be used to move a force, referred to as a load, through a distance. In equation terms, W equals Fs, work output equals load times distance moved by load. If there were no energy losses inside our machine, then work input equals work output, effort times distance moved by effort equals load times distance moved by load. So, if the machine has been designed so the distance moved by the load is less than distance moved by the effort, then the load can be greater than the effort. This means a small effort can be used to move a large load. For example, imagine a machine that when an effort of 100 Newton is moved through 2 meters, it moves a load through a distance of 0.5 meters. We can determine the maximum value of the load. Effort times distance moved by effort equals load times distance moved by load. 100 Newton times 2 meters equals load times 0.5 meters. 200 joule divided by 0.5 meters equals load. Load equals 400 Newton. The same logic could be used to show it is possible to move a smaller load a bigger distance than the distance moved by the effort. The term simple machine refers to a machine that is, well, simple. This has lots of interpretations, including a device that only requires a single force to work, a device for doing work that has only one part, a device that uses a single effort to do work against a single load force. Simple machines are often described as the elementary building blocks from which all other machines are made.